All right, today we're going to be doing a few problems out of section of 5.5. Now we're only going to be looking at what are called the double angle identities. So again, I want you guys to have your trig tables in front of you and your identity sheet. I believe it's over in the right-hand column. You're going to look for the identities that say double angle identities. That's what we're going to be focused on today. So I'm not going to write all those out here for you. You've got those staring you in the face. Now, let me give you an idea of what you'll be doing with those on this unit's homework. So let's say that I give you a right triangle, and I'm going to tell you that this side is 24 and this side is 7. I'm going to tell you that this angle here is theta. Now we can use the Pythagorean theorem to go ahead and find that the other side here is 25. And if we go back to just some old stuff, I can ask you some simple questions of what's the sine of theta? And we know that the sine of theta is the opposite over the hypotenuse. So that would be 7 over 25. I can say, what's the cosine of theta? And that's adjacent over hypotenuse. So that would be 24 over 25. And I can say what's the tangent of theta, and that's opposite over adjacent, so that would be 7/24. So that's old stuff. Now, if I say what's the sine of 2 theta, that now is a new identity. So for the sine of 2 theta, that's equal to, looking at your identity sheet, that is equal to 2 times the sine of theta times the cosine of theta. Well, we just found what the sine and theta, what the sine and cosine of theta were. So that's 2 times the sine of theta was 7 over 25. The cosine of theta was 24 over 25. And now I can go ahead and multiply all those together straight across and get my answer. So 14 times 24, 25 times 25. I know that 25 times 25 is, let's get our calculators out here, 25 times 25 is going to give me 625 over, and then 14 times 24 gives me 1056 over 625. That would be your answer for the sine of 2 theta. To find the cosine of 2 theta, now that's one where you have a few different options. You have 3 to pick from. I'm just going to pick the first one, which is cosine squared theta minus sine squared theta. Well, cosine was 24/25, so I've got to square that, minus sine was 7/25, so I have to square that. That's going to give me, let's see, 24 times 24, that's 576. Sorry, my pen is not working well here. Over 625. Minus 49 over 625, and then 576 minus 49 gives me 527 over 625. So that's my answer for the cosine of 2 theta. Well, to find the tangent of 2 theta, since I already have the sine and cosine, I'm just going to do 1056 over 625 divided by 527 over 625, because tangent is nothing more than sine over cosine. So that's 1056 over 625 times 625 over 527, and I can see that those cancel, giving me a tangent 2 theta of 1056 over 527. So that's my answer for the tangent of 2 theta. Now, we can also solve equations with double angles in them now. So if I say solve for me the sine of 2 theta minus the sine of theta equals 0, what I need to do there is still use my new identity and say that sine of 2 theta has to become 2 sine theta cosine theta. The minus sine theta stays, and now this is like having 2xy minus x. These both have a sign in common, so I'm going to take out a sine theta, which is going to leave me 2 cosine theta minus 1. And now that I have it factored, I can set that equal to 0, set that equal to 0, and say that either sine of theta is 0 or 2 cosine theta minus 1 is 0, which really is going to mean that cosine theta equals 1/2. Now I can go to my trig table and find that sine is equal to 0 at 0 and at 2 pi and also at pi, and cosine is equal to 1/2 at the value pi over 3 and 5 pi over 3. So if I'm only looking for my answers in between 0 and 2 pi, that would be my set of answers. So one more here. If I were to say now solve this one, the cosine of 2 theta minus the cosine of theta equals 0. Again, I have to replace this with something. Now, cosine is one where you have 3 options of things to replace it. So what I'm going to choose to replace it with is going to be the one that only has cosines in it. Now, we know that it's equal to cosine squared minus sine squared, but if you keep looking, you can see that it's also equal to 2 cosine squared minus 1. That's an alternative version of the cosine of a double angle. The minus cosine's just hanging around. Now if I reorder this, that gives me 2 cosine theta minus cosine theta minus 1 equals 0. I can now factor that. 2 cosine theta times cosine theta equals 0, and then I would need a minus 1 here and a plus 1 here to make that work. And then I can set both of those equal to 0 and solve. So 2 cosine theta plus 1 equals 0 is going to give me cosine of theta equals negative 1/2. Here, cosine theta minus 1 equals 0 is going to give me cosine of theta equals 1. And then I can go to my trig table and find out that cosines equal to negative 1/2 at 2 pi over 3 and at 4 pi over 3, and cosine is equal to 1 at 0 and at 2 pi. So those would be my 4 answers for that question. So that's what I want you guys doing with your double angle identities.